everyone, welcome to Technogate. Myself, Jagan. I'm the physics faculty in Technogate. In last videos, we discussed about atoms in Rutherford atomic model. After that, Bohr's atomic model. In Bohr's atomic model also, we discussed something. Bohr's postulates, then radius of orbit and velocity of orbit. And something we discussed about energy of the electron, which is the potential energy, kinetic energy and total energy. And also the ratio of the potential energy, kinetic energy, total energy also we discussed. And here another form, just I remind it, energies equations. Potential energy is equal to minus 1 by 4 pi epsilon naught into E square by R. Kinetic energy is equal to 1 by 8 pi epsilon naught into E square by R. Total energy is equal to minus 1 by 8 pi epsilon naught into E square by R. These are the formulas we have given. Ratio also given. Ratio is 2:1:-1. Right. Now, in another form of the potential energy and kinetic energy and total energy of electron, which is revolving around the nucleus. Right. So, another form is potential energy. So first of all, kinetic energy. Kinetic energy is equal to 1 by 8 pi epsilon naught into E square by R. If we substitute R value here, R is radius, n square h square epsilon naught by pi m E square. That is the value of R, radius of the orbit. If we substitute it, we will get like this. Kinetic energy is equal to right now m e power 4 by 8 n square h square epsilon naught square. So this is the formula, another formula of the kinetic energy. M e power 4 by 8 n square h square epsilon naught square. Right. Next, and at the same time, potential energy is also minus. Potential energy is always negative because it's attractive nature, always negative. Minus m e power 4 by 4 n square h square epsilon naught square. 4 n square h square epsilon naught square. Now, this total energy is sum of potential energy plus kinetic energy. If you add these two, m e power 4 by 8 n square h square epsilon naught square minus m e power 4 by 4 n square h square epsilon naught square. Then we will get like this one. So if you add this one, En is equal to minus m e power 4 by 8 x square h square epsilon naught square. That is equal to total energy minus m e power 4 by 8 n square h square epsilon naught square. So this is the formula. So what are the formulas? Potential energy formula is what? Minus m e power 4 by 8 4 minus m e power 4 by 8 4 n square h square epsilon naught square. Similarly, kinetic energy is equal to m e power 4 by 8 n square h square epsilon naught square. Total energy is equal to right now minus m e power 4 by 8 n square h square epsilon naught square. This is the formula. Now, the ratio, if you take a ratio total energy is to potential energy is to kinetic energy. Total energy is to potential energy is to kinetic energy. -1 is to 2 is to 1. So this is the ratio. Okay. Now we get total energy. Total energy is total energy of electron. Total energy of electron, which is revolving around the nucleus in a stationary orbit. Whatever we have discussed, మనం ఏమైతే డిస్కస్ చేస్తున్నామో అవన్నీ కూడా న్యూక్లియస్ చుట్టూ తిరుగుతున్న ఎలక్ట్రాన్ గురించి చెప్తున్నాం, రైట్? సో ఇది న్యూక్లియస్ చుట్టూ కూడా ఎలక్ట్రాన్ తిరుగుతుంది, రొటేట్ అవుతుంది. సో దీనికి కొంత రేడియస్, వెలాసిటీ, పొటెన్షియల్ ఎనర్జీ, కైనెటిక్ ఎనర్జీ, టోటల్ ఎనర్జీ. సో these things we have discussed. Now for hydrogen atom, if you substitute all constant, so what is the energy of the electron in a first orbit? What is the energy of electron in a second orbit? What is the energy of electron in a third orbit in a hydrogen atom? Because Bohr atomic model is explains only for single electron elements system, right? So now energy of electron in orbital, stationary orbit. We know that En is equal to this is the energy minus m e power 4 minus m e power 4 by 8 n square h square epsilon naught square minus m e power 4, or we can say it's a z square. Minus m e power 4 z square. Z is the atomic number, E is the electron, E is the charge of the electron, right? So m is the mass of the electron, E is the charge of the electron, 8 we know that n is the principal quantum number, h is Planck's constant, epsilon naught is permeability. If you substitute all these things, right, En is equal to, right, minus 13.6 into z square by n square. If you substitute this value and also this value, so then the variable is z is variable and n square, sorry, h square is one, n square is variable. So this is the formula. This is the energy of the electron in a circular orbit. En is equal to what is the formula of energy of electron? Minus 13.6 into z square by n square, right? Now, so what is the exact value of the energy of electron in a first orbit of hydrogen atom, second orbit of the hydrogen atom? So how these energies will vary, right? Now En is equal to minus, this is very important formula, 13.6 into z square by n square, electron voltage. This is the formula. For hydrogen atom, now we are discussing about only for hydrogen atom. For hydrogen atom, z value how much? 1. Z is equal to 1. Right. Now, here I have taken this hydrogen atom, nucleus of the hydrogen atom, electrons are revolving. If electron is in a first orbital, so this is equal to n is equal to how much? 1. N is equal to 1. If electron in the first orbit, then what is the energy? N is equal to 1. E1 first orbit is equal to minus 13.6. Z value is 1, N value is 1. So minus 13.6 electron volts. This is the energy of electron in a first orbit of hydrogen atom. First orbit of a total energy of the electron. Right. Now it has minus 13.6. Then what about this second orbit? How much energy that the electron have in a second orbit? Right. So second orbit. So second orbit means N2. N is equal to N value is how much? 2. Z is equal to how much? 1. E2 is equal to minus 13.6 into Z square by N square. Z is 1. 1 by 1 square by 2 square. That is equal to 4. That value is equal to approximately equal to minus 3.4. What is the energy of electron in a second orbit? 3.4. Then what about third orbit? Third orbit E3 is equal to minus 13.6 into Z square and 1 square by third orbit means 3 square. 3 square means 9. Minus 13.6 by 9. If we do this one, we'll get minus 1.51 electron volts. Minus 1.51 electron volts. What about fourth orbital? So this is third orbital. Then fourth orbital. En is equal to minus 13.6 into Z square by N square. Z value is 1. N is 4. Then minus 13.6 by 4 square. That is equal to 0.85 electron volts. 0.85 electron volts. That means the total energy, the basic formula of the energy formula is En is equal to minus 13.6 into Z square by N square. So this is the energy of the electron which is revolving around the nucleus. In first orbit, N is equal to 1. Then if we substitute, En is equal to, so here if you observe, this is the diagram. If you observe it, now in a first orbit, we'll get like this, minus 13.6 electron volts by substituting this equation. That means this is the ground state. So N is equal to 1, first orbit or ground state, the value of the electron is minus 13.6. So the electron is revolving around a nucleus in a stationary orbit which has a energy is minus 13.6 in a first orbit. So next orbit, it is only applicable for hydrogen and single electron systems. Right. Next, what about second orbital? So second quantum number, second orbital, N is equal to 2. So how much energy it has? It has minus 13.6 into 1 square by 2 square. So minus 13.6 by 4. That is equal to 3.4. What about third orbital? So N is equal to 3. So minus 13.6 1 square by 9. That is equal to how much? Minus 1.51. What about fourth orbital? Minus 13.6 by 4 square is equal to minus 0.85. If you observe here, minus 0.85. Right. What is fifth, sixth? Then what about nth orbital? Nth orbit in the sense the electron which is almost out of the atom. So if electron is out of the atom, then it has a energy is 0. At infinite, the energy of electron is 0. At first orbit, the energy of electron is minus 13.6 electron volts. Right? Now, if you observe this sequence, if you observe this sequence, the gap between the, if you observe and if you write like this, the gap between the first orbit to first energy state to second, we can call it say energy states. Ground state to first energy state, and second, third, fourth. This is called ground state. This is called first excited state. N is equal to 2 is called first excited state. N is equal to 3. N is equal to 2 is the first excited state. N is equal to 3 is the second excited state. So N is equal to 3 is the second excited state. This is third excited state. Right. Second orbit or first excited state. That is called N is equal to. Second, third orbit and second excited state. That is equal to N is equal to 3. Fourth orbit or third excited state. N is equal to 4. Like this. If you observe this pattern, the energy gap. So here minus 13.6, here it is a minus 3.4. Minus 3.4. So the gap between this one, minus 13.6 to minus 3.4, that is equal to approximately 10.5 electron volts. The gap between the, if an electron jumps from lower energy state to higher second orbit, we have to give this much of energy, or minus 10.5, right? So now, so what about this one? Minus 3.4 to minus 1.5, minus 3.4 to minus 1.5. So how much here? 1.9 electron volts. Here it is 10.5, so 1.9. So like this, the gap between the two adjacent excited states will be decreases. Then whenever it is infinite, say like this, it's almost merged with that. Right? Now, if you observe here, this is the ground state. N is equal to 1, ground state, that is equal to minus 13.6. N is equal to first excited state, minus 3.4. N is equal to 3, second excited state, minus 1.5. That means that electron has that much of energy. N is equal to 4, 0.85. So like this, all this 1 year old N is equal to minus 13.6 by N square formula substitution. So infinite దగ్గర ఈ గ్యాప్ అనేది డిక్రీజ్ అవుతుంది. ఇన్ఫినిట్ దగ్గర అన్ని కూడా మెర్జ్ అవుతాయి, అన్ని కూడా మనకి మెర్జ్ అవుతాయి. నౌ నెక్స్ట్ థింగ్, now here if here we are discussing about, this is the nucleus, around this nucleus, this is the first orbit, it's a second orbit, it's a third orbit. N is equal to 1, N is equal to 2, N is equal to 3. We can call it a ground state, it's a first excited state, it's a second excited state. So here it has, in first excited state it has minus 13.6 electron volts. It has minus 3.4 electron volts. It has minus 1.51 electron volts. Like this, if you go to the infinite, energy is equal to how much? 0. At infinite, energy equal to 0. Now, whatever the electron is rotating in a first orbit or ground state, if you remove the electron from ground state to infinite or out of the atom, if you remove electron from ground state to out of the atom or infinite, how much energy is required to remove the electron from ground state to infinite. ఎంత ఎనర్జీ కావాలి గ్రౌండ్ స్టేట్ నుంచి ఇన్ఫినిట్ తీసుకెళ్ళడానికి, ఎంత ఎనర్జీ కావాలి మనకి? దట్ ఈస్ ఈక్వల్ టు ఎంత ఎనర్జీ ఇక్కడ నుంచి పోతుంది అంటే E1 ఈజ్ ఈక్వల్ టు -13.6 ఎలక్ట్రాన్ వోల్ట్స్. ఎక్కడ పోవాలి? ఇన్ఫినిటీకి. అక్కడ ఎనర్జీ ఎంత? 0 ఇన్ఫినిటీ. Then how much energy is required? So E2 minus E1, that is equal to 0 minus of minus 13.6. That is equal to 13.6 electron volts. 13.6 electron volts are required to remove an electron in a ground state from ground state to infinite. This is nothing but a ionization of the electron. Ionization, we can call it a ionization energy. Ionization energy అంటే ఏంటి? ఒక ఎలక్ట్రాన్ ని ఒక స్టేట్ నుంచి గ్రౌండ్ స్టేట్ కానీ ఫస్ట్ ఎగ్జైట్ స్టేట్ కానీ సెకండ్ నుంచి కానీ మనం అవుట్ ఆఫ్ ది యాటమ్ తీసుకెళ్ళడానికి ఎంతైతే ఎనర్జీ ఇవ్వాలో దాన్ని ఏమంటే అయోనైజేషన్ స్టేట్. సో ఇప్పుడు గ్రౌండ్ స్టేట్ లో దాకా ఉన్న ఎనర్జీ ఎంత? -13.6. సో ఇంత మనం -13.6 అయితే ఎక్కడ పోవాలి? ఇన్ఫినిటీకి వెళ్ళాలి. ఇక్కడ నుంచి మనం +13.6 ఇస్తే ఇది బయటికి రైట్. ఫర్ ఎగ్జాంపుల్ ఎట్ ద సేమ్ టైం ఫస్ట్ ఎగ్జైట్ స్టేట్ లో ఎంత ఉంది ఎనర్జీ? ఎంత? 3.4 ఎలక్ట్రాన్ వోల్ట్స్. ఇక్కడ నుంచి మనకి అయోనైజేషన్ ఎనర్జీ ఫస్ట్ ఎగ్జైట్ స్టేట్ ఆ సెకండ్ ఆర్బిట్ లో నుంచి ఎలక్ట్రాన్ ని రిమూవ్ చేయాలంటే ఎంత ఎనర్జీ ఇవ్వాలి మనం? హౌ మచ్ ఎనర్జీ హ్యావ్ టు గివ్? 3.4 ఎలక్ట్రాన్ వోల్ట్స్. సో దీస్ ఆర్ ది థింగ్స్. Right. Now, how much energy you have to do? 3.4 electron volts. At the same time, here also 1.51 electron volts. Right. So now, like this, we have to give some energy. This is called ionization energy. It's called ionization energy. So what we have discussed, I will summarize here. The energy of electron is how much? -13.6. Energy of electron is how much? It's a very important point. That's why repeating here. -13.6 m square by z square by m square. So if it is rotating a first orbit, E1 is equal to -13.6 electron volts. Second orbit or first excited state, that is equal to -3.4 electron volts. Third orbit or second excited state is equal to -1.5 electron volts. Fourth orbit or third excited state is equal to -0.85 electron volts. దీన్ని మనం గ్రౌండ్ స్టేట్ నుంచి బయటకు పంపించాలంటే ఎంత ఎనర్జీ ఇవ్వాలి మనం? 13.6 electron volts. దాన్ని ఏమంటే మనం అయోనైజేషన్ ఎనర్జీ. We can call it as a ionization energy. So second orbit నుంచి పంపించాలంటే 3.4 plus 3.4. Here also plus 1.5. Here also 0.85. Right. One more thing is ground state. Ground state ki if you increase the principal quantum number, the gap is decreases. If you increase the principal quantum number, the gap between any two energy levels are decreases. Right. So this is the energy of the electron which is rotating around the nucleus. Next thing. Next one. What is the frequency? We have discussed about the energy of the electron. Then what is the frequency? Frequency of what is the frequency? Now E2 minus E1. For example, this is nucleus. This is ground state. It's a second exit state. E1, it is E2. ఇక్కడ నుంచి ఎలక్ట్రాన్ ఇక్కడికి వెళ్ళాలి. E1 నుంచి ఇటుకి వెళ్ళాలి. లేకపోతే how much energy is required to move from E1 energy state to E2 energy state, or how much energy is released from E2 to E1. లోయర్ లెవెల్ నుంచి అప్పర్ లెవెల్కి వెళ్ళినప్పుడు ఎనర్జీ అనేది ఎక్కువ అవుతుంది, అప్పర్ లెవెల్ నుంచి లోయర్ ఎనర్జీకి వచ్చినప్పుడు ఎనర్జీ అనేది రేడియేట్ అవుతుంది, రిలీజ్ అవుతుంది ఇన్ ద ఫార్మ్ ఆఫ్ ది ఎలక్ట్రోమాగ్నెటిక్ వేవ్. రైట్, హౌ మచ్ ఎనర్జీ ఇస్ రిలీజ్డ్ ఆర్ హౌ మచ్ ఎనర్జీ ఇస్ అబ్జార్బ్డ్, దట్ ఈస్ E2 minus E1 minus E2. How much energy is released? This is for higher level to lower level is equal to minus 13.6 into, right, E1 is equal to minus 13.6 into z square by n square, and E2 is equal to minus 13.6 into z square by n square. Minus 13.6 common this time 1 by n f square or n2 square. n2 square minus 1 by n1 square. This is the one basic formula. This is the energy is equal to minus 13.6 into 1 by n2 square minus 1 by n1 square. So this is what energy? ఏం ఎనర్జీ అంటే హయ్యర్ లెవెల్ నుంచి లోయర్ లెవెల్కి ఒక ఎలక్ట్రాన్ జంప్ అయినప్పుడు మూవ్ అయినప్పుడు ఎంతైతే ఎనర్జీ రేడియేట్ అవుతుందో, ఎంతైతే ఎనర్జీ మనకి వస్తుందో, రిలీజ్ చేస్తుందో, దట్ ఈస్ ఈక్వల్ టు ఫార్ములా minus 13.6 1 by n2 square minus 1 by n1 square. Then what is the frequency? What is the frequency of the radiated wave? Frequency ఎంత రిలీజ్ చేస్తుంది? We know that delta E is equal to E is equal to h mu, E is equal to h mu, delta E is equal to h into mu. Mu is nothing but frequency, right? Mu is equal to delta E by h. Actually here minus 13.6 into z square r c into 1 by n1 square n2 square minus 1 by n1 square. This is the actual formula. Minus 13.6 into, sorry, z square the formula. Right. Now, if you want to find out the frequency, delta E value తెలుసు మనకి, h value తెలుసు, దాన్ని దీంతో డివైడ్ చేస్తే వస్తుంది. Right. So this is the one more formula. Next one, frequency. Next, wave number. Wave number is nothing but wave number అంటే దీని v bar ని డిగ్రీ చేస్తాం. Wave number is nothing but v bar, that is equal to 1 by lambda, 1 by lambda. v bar is equal to 1 by lambda is equal to r z square. This is the formula, r z square into 1 by n square, n final square minus 1 by n initial square. This is the one of the formula. That means whenever a electron is jumps from higher energy level to lower energy level, it radiates energy, it releases energy, right? And that energy has some particular wavelength. That wavelength is nothing but this formula. What is the formula? What is the relation? We can call it a wave number. V bar is equal to 1 by lambda. Lambda is nothing but a wavelength of energy which is radiated, which is released from whenever electron jumps from higher level to the lower level. It is equal to r z square into 1 by nf square. Nf is nothing but a final state. Ni is nothing but a initial state. ఎక్కడి నుంచి అయితే వస్తుందో ni అంటాం, ఎక్కడికి వస్తుందో దాన్ని ఫైనల్ అంటాం. రైట్, ఫర్ ఎగ్జాంపుల్ ఇలా ఉంది n is equal to 1, n is equal to 2. ఇక్కడ ఎలక్ట్రాన్ ఉంది, ఎలక్ట్రాన్ ఇక్కడి నుంచి ఇక్కడికి వస్తుంది. ఇప్పుడు ఇనిషియల్ ఎక్కడి నుంచి వస్తుంది మనకి? సెకండ్ నుంచి. ఎక్కడికి వస్తుంది? 1. రైట్, that is called 1 వస్తుంది. సో ఫైనల్ ఈజ్ నథింగ్ బట్ 1, ఇనిషియల్ ఈజ్ నథింగ్ బట్ 2. ఇక్కడ నుంచి మనకు వస్తుంది కాబట్టి ఎలక్ట్రాన్, ఇట్ రిలీజ్ సమ్ పర్టికులర్ ఎనర్జీ. ఎంత ఎనర్జీ యొక్క వేవ్ లెంగ్త్ ఎంత? lambda. So like that we can find out the energy wavelength. So next, after this one, we have a spectrum. We have a hydrogen spectrum. So here in this video, I have discussed about energy, kinetic energy, potential energy, total energy, right? The ratio of the potential energy, kinetic energy, and total energy. Then after that, we discussed about energy of the electron in the ground state, first orbit, second orbital, first excited state, third orbital, second excited state, right? The relations, then whenever how much energy is released from whenever it releases from higher orbit to lower orbit, right? How this ground state, from ground state to higher excited state, how this phenomena is decreasing, the gap is decreasing. One more thing is ionization. How much energy is required to remove an electron from atom to the atom to different. So all these things we have discussed. In next chapter, we discuss about the hydrogen spectrum and limitations of the Bohr's atomic model. So thank you.